A lone stick traveler named Nova drifts through space that feels like a giant lukewarm bathtub. Every direction shows the same gentle glow, nothing brighter, nothing dimmer. Our playful puzzle: could anything alive thrive in such flat calm? First, life needs energy flowing, just like a windmill needs wind. But equal warmth means no thermal wind, only a dull sigh of photons. Nova tries solar panels. They output less power than a snail sneeze. Why so weak? Nova grabs a crayon-covered napkin for some back-of-the-napkin math. 20 degrees C radiation is about 400 watts per square meter, but everything else shines back exactly the same. Perfect symmetry cancels useful push, like rowing on glass still water. So the first possible beings must steal stored energy, not moving heat. Enter the chemist sprites, tiny bubble creatures hoarding chemical bonds forged before the great equalizer. Nova imagines them as puffy marshmallows filled with reactive candy. They crack the candy for energy, kind of like pop rocks and soda. Yet once the stash runs out, game over. Could a fancier trick exist? Maybe quantum fluctuations, the jitter of emptiness, can be siphoned. Nova builds a theoretical zero-point straw, then frowns at the cost. Calculations show it needs more material than the visible universe to power a toaster. So, quantum dinner is cancelled. Another hope: gravitational tides from wandering planets. But equal temperature likely means no stars, and therefore no planets. Nova waves goodbye to that route too. Instead, she looks inward, literally. Living cells could burn differences inside themselves, like a hot core and cool skin. Imagine a hollow sphere creature, core packed with slow radioactive salts. Its membrane radiates heat, core stays hotter, energy trickles outward, powering metabolism. Nova names them thermonauts because they create their own gradient. Thermonauts eat rock dust laced with uranium sprinkles. Nova wonders, how many sprinkles are needed for a 1 kilogram body? Quick math: about 1 part per thousand of uranium, similar to backyard granite. So raw materials exist if lumps drift together by chance. Yet drifting is slow in a silent universe. Enter magnetism, the quiet matchmaker. Iron grains align like compass needles, clumping into spiky snowballs. Thermonauts could ride those clumps, meeting, merging, sharing heat. Nova sketches two spheres hugging, trading thermal kisses, adorable and functional. Social energy networks form, like cuddling penguins in Antarctica. Where there are gatherings, there is competition. Some thermonauts evolve thicker shells, stealing neighbors' radiation before giving any back. Predators and prey finally appear. Heat vampires versus heat farmers. Nova cheers. The first cosmic drama begins. Can such drama birth intelligence? Surprisingly, yes, because strategy saves calories. Smarter vampires coordinate raids. Farmers strengthen defenses. Both sides invent signals. Signals start as rhythmic dimming, like winking porch lights. Over eons, the patterns become language. Nova eavesdrops on heat Morse code gossip about resource maps. With language comes planning, then tools. Tools here are shape tweaks. Think scalloped shells that focus outgoing photons. Focused beams act like light-etched blueprints, guiding spores to copy the design. Hello civilization made of shining nested bubbles. They orbit each other, forming lattices, a cosmic honeycomb city. Inside, communication is billions of times slower than human speech. Residents do not mind. They measure time in millennia-long heartbeats. Nova politely asks, could they ever build rockets? Rockets need thrust, which needs gradients, something they barely have. So expansion means growing chain by chain, not blasting off. Their art, however, flourishes as elaborate thermal sculptures. Imagine a cathedral where walls glow cooler, spires glow hotter, melodies in infrared. Nova now wonders, could such beings evolve into carbon critters like us? Short answer: extremely unlikely, but let's daydream anyway. Suppose the uniform temperature slowly fractures, perhaps by dark energy mischief. Pockets cool, pockets warm, new gradients explode across space. Our bubble folk have already mastered internal heat control. They repurpose that know-how to ride the new currents. Parts of shells melt, producing organic polymers by accident. Polymer membranes trap water, chemistry speeds up, complexity snowballs. Within a billion more years, wiggly carbon offshoots sprout fins and eyes. Nova narrates, these are grandparents of fish, though they still worship heat. Eventually, some crawl onto nascent planets that just formed around fresh stars. The familiar story follows, fins to legs to tweets complaining about Mondays. So in a wild chain, uniform heat life could seed us, but only is the calm later shattered. Nova scribbles a chart linking glowing bubbles to coffee-slurping humans. Next question: how could we ever confirm these ancestors existed? Clue 1. Leftover tungsten isotopes in interstellar dust might record their shell forges. Clue 2. Faint cosmic microwave ripples, shaped like honeycomb shadows. Clue 3. Exotic neutrino flavors from miniature reactors inside ancient corpses. Our telescopes today lack that sensitivity, but upcoming arrays might catch whispers. Nova plugs numbers. Sensitivity must improve by a factor of 100. That's like upgrading your phone camera to spot a candle on Mars. Achievable, but the coffee budget will suffer. Now every good journey ends with a twist. Equal temperature might never have happened because expansion cooled everything unevenly anyway. Yet thinking about it sharpens our intuition about entropy, the universe's tidy housekeeper. Entropy says, without differences, nothing interesting moves. Nova nods, then secretly thanks pesky unevenness for sunsets, pizzas, and playlists. Good news, we get music. Bad news, cosmic spa day cancelled. Time for a final math flourish. If the cosmos stayed at 20 degrees Celsius forever, background energy density would be about 1 microjoule per cubic meter. That's less than the energy of one floating dust mote. So even heat is calm but dull, like an endless elevator music loop. Nova drops the microphone, which never falls because microgravity. Instead, she leaves a glowing sticky note. Differences power dreams. The honeycomb city fades into a starry future that finally features real stars. Takeaway: cherish chilly mornings and hot tea. They make life crackle. Nova sips tea beside a campfire shaped like the universe. Your stick figure self floats in, holding a spare thermometer. Remember, if everywhere feels identical, nothing cooks, nothing cools, nothing thrills. So celebrate gradients. They turn dull soup into cosmic stew. Nova waves goodbye, promising fresh absurd questions in the next adventure. Final wink. A rogue thermonaut sneaks in, hawking souvenirs. One final blue blit flickers, then silence.